Hello. Today we will proceed with discussing sample regression line and using ordinary least squares method for estimating sample regression line. So just to remind you what it looks like, this is a sample regression line. So on vertical axis we have dependent variable, on horizontal axis we have independent variable. So y hat stands for expected value of dependent variable in sample regression line, and yeah, it depends on the value of independent variable. So as you also remember, the distance between empirically observed value of dependent variable and expected or predicted value of independent variable is denoted as error term. So in perfect universe, there would be no difference between expected value of dependent variable and empirically observed value of dependent variable. However, this is not the case. Whatever you do, your regression line is never good enough to go through all of those empirical values. It's impossible. So you're just interested in making it as good as possible. And what I mean is to minimize the sum of square distances between the regression line and empirical values of the dependent variables. I will explain. So again, error term stands for the distance between expected value of y and empirically observed value of I. But we're not interested only in this observation. We want to minimize this distance for all the observations. That's why we minimize the sum. So if we sum all of those distances, we will get what we're interested in. However, if you minimize the sum, you will not account for the fact that you are not interested in the direction. So take a look. In this case, empirical value of y is higher than predicted value of I. In this case, empirical value of y is smaller than predicted value of y. And actually there is no difference for you in terms of estimation. So that's why you have to put all of those error terms to the power of 2, because in this case, regardless of whether this difference is positive or negative, you will always get a positive value, and only then you have to sum them and minimize the sum of those distances. This is how it works. So, of course, some assumptions have to be maintained if you want to interpret OLS output as sample regression line. And basically, this is what we will start discussing in today's lecture. Before we proceed, I would like to introduce a piece of economic theory on which today's regression is based on. So Kuznets curve describes the relationship between per capita income and the level of income inequality. Kuznets curve is an inverted U-shaped curve, and basically it tells you that when the level of per capita income is relatively low, increase in the level of income will result in increase in the level of income inequality. After this function reaches its maximum, the highest possible level of income inequality, then increase in per capita income will be associated with decrease in income inequality. So for this portion of function, we have positive relationship between the variables, and after function reaches its maximum, it turns to be negative. Please keep in mind that this function is not linear. You have different rate of change. So positive slope, then negative slope. The function grows fast when the level of per capita income is low, and it slows down when per capita income increases, and so on. So the mathematical model would look in the following way. When you add both linear term of GDP per capita or per capita income and square term of per capita income. If our intuition is correct, and the relationship between per capita income and income inequality is indeed described by this function, then beta 1 and beta 2 should be negative. But of course you do not specify it when you run the regression model. This is just what you expect to obtain. This is our hypothetical values of beta 1 and beta 2. So the first assumption of OLS is linearity in parameters. So please remember that we assume that beta 1 is linear in our case. It's not true for independent variable. Actually, it can be linear. You can take the square root. You can put this variable to the power of 2. And still this assumption will be maintained. So based on this, you can definitely see that regression model linear in variables is not the best choice. However, I will run the model with linearity in variables for purpose, just to show you how this might complicate the output and how it can make the output of your model invalid. So we'll use Gretel. You usually start with importing the file. So today we use inequality training set. So please choose the proper type of file, and please do not use XLSX types of files. It should be XLS. I do not know why, but for some reason Gretel does not want to import other types of Excel files. So we use this one, open, okay. Yeah, I know there are some missing values. Oh, and this is important. By default, Gretel interprets all the data as cross-sectional data. However, I'm using panel data set. So I will use index variables. ID and year are just the names of columns in my Excel spreadsheet. By the way, you can find it in the materials for this lecture. So ID stands for country ID, this is group index variable, and year stands for time index variable. Yeah, so I analyzed 264 countries for 28 years. Yeah, so now I will run the model. I specify Gini, which stands for the level of income inequality, as dependent variable. So please remember that a higher level of Gini coefficient means higher level of income inequality. It's very important when you interpret the results of your output. And GDP per capita will stand for independent variable. So this is my regression output. I can do some kind of visualization. So then I again specify GDP per capita as x-axis variable and Gini as y-axis variable. Yeah, so this is just the visualization of regression line together with those empirical values. What you have on this slide. So the results of estimation show that increase in the level of per capita income results in decrease in the level of Gini coefficient and consequently the level of income inequality, because lower value of Gini coefficient means lower value of income inequality. So that's why this regression line has a negative slope in contrast to what we analyzed here. In this case, we assume positive relationship between x and y, and in this case, it turns out to be negative. And this is typical estimation output with the number of observations, information about number of cross-sectional units and periods, and so on. So there is plenty of helpful statistics. This is not something we will not concentrate on today, although we will analyze some of those values. And in the next videos, we will proceed to the further assumptions about OLS and how to verify whether your model fulfills those assumptions. So just to summarize, the first one was linearity in parameters. So thank you for your attention and see you in the next video.